Hi, everyone. Today we're going to learn something new. We're going to learn about a topic called correlation. I'm going to go over explaining what correlation is, and we're going to see how we can solve questions involving this. Now, what is correlation? Before I start, variables, right, can have relationships. Imagine, for example, let's do something very simple. Let's say that you sleep 8 hours a day, and you notice that sleeping 8 hours a day helps you do well in class. And so there is a relationship between the number of hours you sleep and how well you do in class. Now, on the other hand, let's say when you sleep less, you do poorer in class. What you've just shown me is that more sleep leads to better grades and less sleep leads to worse grades. So there is a relationship between sleep, or the amount or the number of hours of sleep, and your performance in your class. That is a scenario where you have two variables and there's a relationship between the two of them. Correlation is what that is called. What correlation does is that it shows a relationship between two variables. Now, why is this important? This is important because it helps us to see if variables are related in any form, right? And what correlation does is two big things. It shows us the direction of the relationship. When I mean direction is it shows if there is a direction in the sense that both of those variables are related or are increasing or decreasing at the same way, or if there's an inverse relationship. An inverse relationship means one variable is increasing and the other is decreasing, and the other way around. Now, one simple way you can tell in correlation is, if you remember, and if you've taken an economics class, you always remember the law of demand, right? The law of demand shows that when price of goods increase, right? So think about it, right? So if you remember, and if you don't know, that's also fine. I'm still going to go ahead and just kind of explain it. Think of it, right? Usually, so let's take $2, $4, $6, let's say 10, let's say 20, let's say 30. Usually when items are cheap, right, we tend to buy more. So in this case, you can see, because this item is $2, right, I bought 30. Now, what happens if the item becomes $6? I'll buy less, right? Why is that? The reason is because maybe my income is fixed. So I'm buying less if the price is high. I'm buying more if the price is low. Just like how people buy more items when there's a sale, right? You buy more items if it's on sale. If it's not on sale, you probably buy less. And we know this, right? And this is an example of a relationship between what? Price and quantity. You can see as price increases, you're buying less items. That is an inverse relationship. It is a relationship, but it's an inverse relationship. We can also have a relationship where both of them are increasing. So think of the other way around. Let's look at, for example, right? Let's say, for example, that a parent says the higher your GPA, the more the parents will give you in terms of allowance. So you can see in that scenario, as your GPA increases, the allowance you get from your parents increases. So in both scenarios, you are seeing both items increasing. That is a scenario where you can see both items going in the same direction. So you can have a positive relationship, which is this one, right? Where your GPA increases, your allowance from your parents increases. Or you can have a negative relationship, which is this one. As price of goods increases, we tend to buy less of those items. So correlation does two things. It shows us a direction, which I just showed you, positive and negative. It also shows you the strength, which we talk about. Now, one way you can show the strength relationship is through using a graph. The problem with scatter plot or a graph is that it might not be very helpful. You can make a good guess, but one of the best ways to do that is to use what we call a correlation coefficient. And so let me explain that. So a correlation coefficient, also written as, it's pronounced rho, but it looks like an R. And what it does is it helps to give you a definite number. So think of it as a form of a percent, basically, or more like a decimal, right? So it ranges from -1 to +1, right? And what it does is that it shows you the strength and the direction of the relationship between two variables, right? And it has a few very easy characteristics that can let you know what the correlation result is. Like I said, it usually ranges from a -1 to a +1, right? As the number goes close to 0, it's showing that you have little to no relationship between those two variables, right? But as it gets close to -1 or +1, it shows a strong or extremely strong relationship between those variables, right? And so, like I said, as numbers goes close to -1 or +1, that's a strong relationship. As the numbers go close to 0, that means there's basically no relationship. So when the correlation is 0, that means there's no relationship between those variables. But how do we come about that number 0? Well, that's very simple. Remember, if you remember when you guys did, when you did your basic algebra in school, one of the things you were taught, right, when it came to linear equation, is that you can tell the slope, right, of a given scenario. You can tell the slope by doing your rise over run, right? And we know that when our straight line is in this form, usually that means it's positive, right? But if it's in this format, then it's negative, right? But when we have a straight line like this, there is no slope, right? And so at this point, it's 0. And so once you have your correlation coefficient at 0, that means that there's no relationship between what your y is and what your x is within those two variables. So that's how we are able to do that. Now, how do we analyze our correlation coefficients? Very simple. Now, when you get a result that is 0, that tells you that there's no relationship between both values. If your correlation coefficient, right, if it is either plus or negative, and 0.1 to about 0.3, it's deemed a weak relationship, right? It exists, but it's not strong, right? It's a weak one. When your correlation coefficient is around 0.4 to about 0.6, we tend to see that as a moderate relationship, right? Some books might say moderately strong, but that's a moderate relationship. That means that the relationship is better than weak, but it's not as strong as you'd want it to be, right? Now, when your relationship coefficient is about 0.7 to 0.9, that is deemed a very strong relationship, right? And so that's a very strong relationship. But when your correlation coefficient is plus or minus 1, we deem that to be a perfect relationship. Extremely strong, and a perfect one, because that's the highest it could be, right? It could range from 0 to 1, right? Just like how your probabilities tend to be. The only problem is that these ones have negative numbers, so we can't call that a probability. So this is deemed a perfect correlation. It could be negative, perfect, or perfectly negative, or perfectly positive, right? Depending on what the symbol is. And you can get that from solving your question, right? Now, what we're going to do real quick is we're going to solve 1 or 2 questions to show you how to find this, and it's extremely easy, right? Now, the first thing you want to do is, so let's look at example 1, right? And let's look at how we can solve this question. This one says that the owner of Alhambra Ford Motors, right, wants to study the relationship between the age of a car and its selling price. So they want to find the age of the car, and they also want to find the selling price of the car. We're told that listed below, right, is a random sample of 12 used cars sold at the dealership during the past year. So what they've done is they want to see what the relationship is between age of a car and the selling price. Now, before I begin to solve this, I want to explain something very clear. Correlation has a few shortcomings. And that's key one is that it's not what? Causation. Right? This is very important, right? Correlation is not causation. And you hear that all the time, and people say that every time, but I wanted to make sure that you understand what that means. Now, causation means cause and effect. So what it means is that one variable affects the other one. Now, correlation does not achieve that. Correlation does 2 things. It shows you the strength of the relationship between 2 variables, and it also shows you the direction, whether it's positive or negative. It doesn't tell you if one variable affects the other, right? So 2 things can have a strong correlation or relationship, but they'll have no effect on the other. They could just happen by chance, right? A simple one I've always said is during the hot period, right? People like to drink ice cream. But at the same time, when the weather is hot, right? Sharks and other fish in the sea, right? They might come closer to the surface or closer to where people are. So you can see, oh my goodness, right? That when there is a high number of people eating ice cream, there's a high number of people being bitten by sharks, right? So you can see in this scenario, those 2 events, there is a strong relationship between the 2 of them. Well, does it mean that people who eat ice cream also have shark biting, or there's a relationship between eating ice cream and getting bitten by sharks? No. It's just a case of 2 things happening at the same time. So it is very possible that 2 events might happen at the same time, but one has no effect on the other one. And that is the biggest shortcoming of correlation, right? All right. Now let's go ahead and solve this question. It's actually extremely easy. So what we're trying to see is if there's a relationship between the age of a car and the price of that car. And we're told to do 3 things. We're told to draw a scatter diagram We're also told to determine the correlation coefficient. And lastly, we're told to interpret the correlation coefficient. So we can do a scatter plot. That's not a scatter plot. That's not difficult. And that's pretty easy. We can just come here and we can select a scatter plot. We can select this. Actually, these ones are not good ones. This is a better one. Okay. So you can see, right, the scatter plot. The direction, like we said, right, you can see this is more this direction. And that kind of tells you, even without solving the question, that tells you that it's more of a scenario where you have a negative relationship, right? You can tell by the direction of the inputs. But let's move further, right? So we've been able to provide that first one. The second one is we're told to determine the correlation coefficient. And this is where we can easily do that. So we can go to our data, to where it says data here, the top. We can go to our data analysis, and we can go ahead and select our correlation. See correlation here. And then we can select OK. And so it allows us to input our data. Right? So we can just go here and select our data. We'll select this two data. You see how we selected that. And then it's asking us, how do we group that? Is it by columns or rows? You can see this is by columns, so that's easy. Now, because we selected age and selling price, we have to click on labels. That way, Excel will not calculate these categories, right, or variables. So we now click on this, and then we click on this white spot. What we're doing here is telling Excel where we want Excel to put our results. And so when you click enter here, and then you press OK. And so you can see as Excel has provided us with the result. This is our correlation coefficient, right? The correlation coefficient here is this value here. And you can see this is 0.5. So you can see this is what we said, it's a moderate low, right? So we can see that there's a negative relationship between age and selling price, but it's moderate, right? So we can see that we can now interpret the results, right? We can see that there is a moderately there's a negative, right, and moderate relationship between age of cars and their selling price. So the relationship is negative and it's moderate. So we can say moderately strong. Right. So we're saying that it's negative, but it's also moderately strong, right? So what we've done here is we are basically in this scenario, we are saying that this relationship is not that strong, it's moderate, but it's negative. But that makes sense, right? Because the older a car is, the less the price of the car would be, selling price would be. So the relationship has to be negative, right? Because when cars get older, so when the age increases, their price does what? Decreases. And so we were expecting to have a negative relationship here. So we're fine on this, right? We were able to get the result that we were confident we're going to get. I hope this makes sense. Another example we can use is, let's try one more, right? And so we get more comfortable with this. Let's look at this one. This one says there's a city council of Pine Bluffs, right? It's considering increasing the number of police officers. So they're thinking of increasing police officers to reduce crime. But before they made that decision, they decided to look at similar cities with the population size that is close to theirs. And so these are the cities. These are the number of police officers they have in those areas, and this is the number of crime. And so what they're trying to see is there a relationship between police officers and crimes? And if there is, what kind of relationship is there between them, right? Is it positive? Is it negative relationship, right? So we're told to do the same thing. We're told to draw a scatter plot. We're told to determine the correlation coefficient. We're told to interpret the correlation coefficient. So we already know how to do that, right? We can go ahead and we can easily do that, right? But you can see, right? This one is actually clearer, right? You can see the values are closer to the line. And so you can see that there's actually seems to be a stronger relationship, right? Because you can see the inputs are close to one another. The closer they are, usually tells you that the relationship is strong. But we can double check, right? We're going to double check to see that, right? That's just going to help us do that. So let's go ahead and do that. So to find the correlation coefficient, we're going to do the same thing. We're going to go to data. We're going to go to data analysis, right? And once we do data analysis, we're going to select correlation. We're going to go ahead and select these values. And we're going to select where the result should be and say here, and press OK. See that? That's a very strong relationship. So we can see that there is a very strong and negative relationship between number of police officers and the number of crimes, right? Remember, even when you see a negative, it means that it could also be indirect. So when you see words like indirect, that means negative. If you hear direct, that means it's positive, right? So sometimes you see words like that used in some books. So you can see it's a very strong and negative relationship between number of police officers and number of crimes, which means the more police officers you have, the less the crime. If you have high crimes, it means you have what? Less police officers, right? And you can see this actually showed us the same thing too, right? So the chief might now decide that based on this scenario, I'm going to hire more police officers because I have the data to prove to me that when I have more police officers, I have less crime. But like I said, correlation is not causation. So this is not going to help us. The better way to help us is actually to do what we call regression, which we're going to discuss in our next video. Regression actually shows you cause and effect, how one variable affects the other variable, which we'll cover in our next video. So I hope this helped you understand this concept, and thanks for watching. For a chance to get extra credits, you can solve questions 5 and question 6 and submit that for extra credit. Thank you.